You must have heard the term big data. In the recent years, this term has been gaining popularity across the industry. There has been a paradigm shift in the volume of information and the ways in which it is extracted from the underlying data. ELK is one such new age method for data exploration. Let's talk more about big data, but before moving ahead, let's first define what big data means. Big data is a blanket term or a catchphrase used to describe any collection of structured or unstructured datasets which are so large and complex that it becomes difficult to process using traditional database management tools or data processing techniques or software architecture. In other words, the dataset volumes are so large that we cannot use tools like spreadsheet tools, relational databases, etc. to process these datasets. In these scenarios, the volume of data is too big or collection of additional data is too fast that processing these datasets exceed the capacity of traditional tools or techniques. Despite these big problems, big data has many benefits. Processing these datasets can help companies and individuals gain better insights about the data or their businesses and improve the operational efficiencies. They say time is money. Using big data processing techniques, you can gain these insights about these large datasets in very short period of time and even almost in real time, which translates to faster and better decisions. With the added capability of big data processing, we can now build new products and services, stretch the boundaries of science, and venture into new research areas which was not possible earlier. One of the biggest reasons of data size growth is that we have billions of additional devices available to the users in shape of smartphones, IoT devices, which are consuming and producing loads of data every second. Internet access and connectivity is becoming ubiquitous in most parts of the world. This makes it very easy for these devices to upload and share this data with others. All this data eventually gets captured for further processing, sharing, and analytics. Let's determine what caused this big swell in the size of datasets in recent years. Let's examine what kind of data growth trends we are experiencing by looking at some numbers from 2012 from popular search media site Facebook. In 2012, Facebook was reported to have 2.5 billion content items posted every day, 2.7 billion likes daily, 300 million photos were uploaded by users every single day. While Twitter has reported 500 million tweets every day, or roughly 200 billion tweets on a yearly basis. Similarly, Google reported 20 petabytes or 20,000 terabyte data processed every day. Let's now move our attention to some traditional datasets. The largest relational database is being used by AT&T, which is about 320 terabytes in size. The AT&T Call Records database has 1.9 trillion unique rows in the database, which is the second largest number of unique rows. It is estimated that 90% of digital data generated by human race has been generated in just past 2 years. 80% of this data is unstructured data like photos. This tremendous growth in data and big data technologies could be characterized with 3 V's. First V is volume. Here, the volume represents the size of data. As we just saw, we are collecting larger and larger datasets ranging in terabytes or petabytes. This is a combination of structured and unstructured data. Next is velocity. This represents the speed at which data is being generated and or is being ingested by our systems. There are applications which are collecting very high velocity data like click streams, signals from IoT devices, server logs, etc. These data streams are being generated at gigabytes per second and are being ingested for further processing. Last V is variety. Variety refers to the different kinds of data that our systems collect. It could be structured data or unstructured data. Structured data follows some recognizable patterns, like comma delimited format or relational data. This structured data is well understood by machines, whereas unstructured data refers to things like photographs, binary files, and so on. For the most part, structured data refers to the information with a high degree of organization. As such, inclusion of this structured data in an organized system like relational database is seamless. This type of data is readily searchable by simple, straightforward search engine algorithms or other search operations, whereas unstructured data is essentially the opposite.